Welcome back, everybody. Let's go to the isometric sphere. And to draw isometric sphere, we require 3 ellipses to be drawn, one along each axis and one circumscribing the first one. So if you look at the isometric sphere, this here you can see 3 ellipses, and here is one, and here is the other one, and this is the actual diameter, but then the entire the circle is 1.22 times this diameter of the circle. So this is an isometric half the sphere. Half the sphere is only show half of it. As you can see, this is just half. Sphere is more like a basketball. Imagine this is your basketball. You only see half the basketball. And this is isometric, the quarter sphere, and you can see it's only 1/4 of the sphere. And the 3/4 is about 70.75 of the sphere. It's gonna look like a heart. So for the flat, and if given this flat surface on a sphere, the way to show that onto the isometric drawing is to find out what the diameter of the circle is and what is the flat area, the diameter of the flat area, and then use the same idea that we learned in the past, and either use a template to draw this ellipse onto the sphere, or you can do it by using the construction method, which is like using the compass. But I would suggest you to use the ellipse, the template. And I want to go a little bit quicker, because I want to finish up this chapter 18 today. So to look at the axonometric drawing and projection, axonometric using or designating an orthographic projection of an object, such as a building, on a plane inclined to each of the 3 principal axes of the object, 3-dimensional but without perspective. If you look at the projection, we have a dimension along the 3 principal edges are foreshortened. Exploded drawing show all the component of an assembly as individual. Isometric drawing assemble the drawing show how a single product looks when assembled. As you can see, I'm going to show you another picture how the exploded drawing looks like. And if you look at this isometric projection causing dimension along the 3 principal edges to be foreshortened to approximately 82% of the true length, note that the diagonal of the 1-inch cube is same as the point in the A view. The 3 edges 3-2, 3-4, 3-7 equal to 0.816. So in other words, if you look at this picture here, you have a 1-inch cube here. Is 1-inch cube, but when you finish your finished product, is only going to show 0.816 inches. This is only 0.816 inches, but the diagonal of the square is equal to 1 inches. So the angle between the edges 3-2, 3-2, 3-4, and 3-7, they're all 180 degrees. So 180 degrees here, 180 degrees, and 180 degrees right there. So the here is one of the good example of the exploded drawing. Show all the component of an assembly. So now it's more like if you put everything together, is you show that that product as assemble. But this is exploded because, as you can see, all the component is separated. That's more like you exploded the product. So isometric assembly drawing appear in 2 popular format, either exploded or assemble format. So exploded isometric drawing show all the component of an assembly as individual isometric drawings, including fashioner. However, the components are aligned in space in the same way they are to be assembled. So this assembler and this is exploded drawing. And let's summarize with types of projection. There are two main types of projection. We have under the projection, we have two main type of projection. We have a perspective projection. We have a parallel projection. And under the perspective projection, we have a linear perspective. We have area perspective. So linear perspective, we have 1-point perspective, 2-point perspective, 3-point perspective, as you can see the picture. And 1 point you only look at from one vantage point, and whereas 2-point perspective you have 2 or 3. Area is like if you go to it's an area with an aerial photo to show the actual 3-dimensioning of the object. And under the parallel projection, we have an oblique projection and we have orthographic projection. The oblique projection, we have a cabinet projection or cavalier projection. So the cavalier projection, we're going to talk about these two projections in the next video. But for the orthographic projection, we have a axonometric projection, and we have a diametric projection, and we have a trimetric projection. We're going to talk a little bit more about this isometric, diametric, and trimetric projection in the next few slices. And here for the multi-view projection, we have a front view, top view, and the right side view. First, the first angle projection, and we have a second angle projection. We have a third angle projection, and we even have the fourth angle projection. So depend which angle projection you want to move forward. For the first angle projection, you start with right side to your front view to the top, whereas the third angle projection, you're from your right side going to the front, going to the top. So let's talk a little bit more in the axonometric drawing and projection. And under the diametric drawing, from here we have axonometric projection. We have a diametric and trimetric. So what is a diametric drawing and what is a trimetric drawing? As you can see from this summary here, the diametric drawing, only 2 of the angles are equal. As you can see, all this angle, you only can find 2 angles are equal, 130 degree, 130 degree, and then same thing here, you only have 2 angles are equal, and there are less distortion of receding line. So there's less distortion of receding line. So for the trimetric drawing, the axes are rotated so that each angle is different and the scales are also different. So if you look at the trimetric drawing here, you see that this type is more realistic, but it's time consuming. So you have none of these angles are, this is all the different angles. Unlike the diametric, we have at least 2 angles are the same. But then for the trimetric, none of these angles are the same, and also the receding line is they only have 2 other scale and 1 full scale. So 2 other scale and 1 full scale. For the oblique drawing, you can see oblique projection. We got all this are parallel, full scale, half scale, any appropriate scale between half and full scale. So you can do, if you look at the oblique drawing, you have cavalier drawing, cabinet drawing, and general drawing. So what is the difference between this cavalier drawing, cabinet drawing, and general drawing? As you can see, the cavalier drawing is the regular front view, and you have a full scale here. And compared to cabinet drawing, everything is the same except it's half the scale. And then for general drawing, any appropriate scale between half and full. So any scale between this and this will be a general drawing. So now let's go into what is a cavalier and also the cabinet drawing. Cavalier drawing is receding. The receding line are at 30 degrees or 60 degrees and draw full size. Cabinet drawing is the same as the cavalier, but receding line are only half the size. General oblique drawing similar to the cabinet drawing, except the drafter may choose any scale they want to. So if you look at the this cabinet drawing have the same range of receding axis as cavalier drawing, but the receding distance are drawn to half size. But then if you look at the cavalier drawing and all this receding line, they're all in full scale. And compared to the cabinet drawing, this is all in half scale. And the general oblique drawing is similar to cabinet drawing, except that the line drawn along the direction of the receding distances may be at any scale between half and full. So this here, full scale, this any scale they want it. This has to be full, and then this receding line can be any scale. Okay, for the perspective drawing, I'm going to end the video here, and we're going to continue on to video number 4.